Alright, hello students, and today we're going to cover exercise 3.4. Some of the questions that was we actually asked you to do for homework, and now we actually go through these questions. So the first question that actually we're going to go through is on question 3 on page 75 of your Discovering Mathematics textbook. So now we look at this question 3. Okay, first and foremost, if you notice the question, they actually give you that 49 is to 36. So what is 49 is to 36 in this case? Since they say that actually it is actually the areas of corresponding faces. So 49 over 36 actually corresponds to A1 is to A2 is equals to 49 is to 36. The ratio of areas, as we know from the previous chapter, is L1 over L2 square, which is the ratio of length square equals to 49 over 36. Then, how do we remove the square? Very simply, what we do is we square root the left-hand side. We also, to balance, we square root the right-hand side. This will remove the square over here. Hence, what we get is L1 is to L2 is equals to 7 over 6. Okay. Do bear in mind that they ask you for the ratio, so your answer actually has written as the ratio is 7 is to 6. Be mindful not to leave your answer as a fraction as seen over here. Now, in 3b, they want you to find the ratio of the volumes of the two cubes. Hence, what we have here in 3b is this. So, as we know, the ratio of volumes V1 is to V2 is equals to L1 is to L2 cube. Where can we get the ratio of L1 to L2? If you remember just now, in the earlier part, in part A, we actually found the ratio of the length itself. Hence, very simply, V1 is to V2 is equals to 7 over 6 cube, which simply works out to be 343 over 216. Hence, for 3b, the required ratio is 343 is to 216. Finally, we can talk, since the volume of the smaller cube is 648, we can find the volume of the larger cube. Hence, for 3c, we let the volume of the larger cube be V, okay, and then the volume of the smaller cube is 648 itself, and we know the ratio of the volumes as we found in part B itself, which is 343 over 216. Hence, I will put 343 over 216 here. Hence, the volume of the larger cube is 343 over 216 multiplied by 648. And over here, what we get for the volume of larger cube is 1029 cm cube. Okay, that is it for question 3. Now we look at question 5, okay, which can be found on page 75. So first they ask you to find the volume of the prism. If you notice the volume of the prism, right, if we just focus down here, the volume of any prism is given by the area of the cross-sectional times the height or the length of the prism. So in this case, what is the shape of the cross-sectional? If you notice, the shape in this case will be that of a pentagon. So in this case, they actually give you that the base area of the pentagon, or the area of the pentagon rather, is 170 cm square. Hence, the volume itself is equals to, the volume itself is equals to 170 times the length of 25. Hence, what we get here is to be a volume of 4250 cm cube. Now, in part B1, they say that a similar prism has a height of 30 cm. Find its base area. So, if we are comparing base areas, what we're actually looking at is L1 over L2 square is equals to A1 is to A2. So, we know that a similar prism has a height of 30 cm. So, now what we are going to do here is this. We set it up, alright? So, we get A, which is the height of the similar prism, divided by the base area of the prism that we already have. All right, the value can be found here. So A1 over A2 is equals to L1 over L2 square. Be very careful here. Is it 25 over 30 or is it 30 over 25? In this case, since we have to use the corresponding length itself is 30 over 25. Don't forget, right, that for lengths you have to square it to get the ratio of the areas. Hence the area in this case will be 30 over 25 square multiplied by 170. If you just use your calculator, you find that the base area of the similar prism will actually give you 244.8 cm square. Okay, now similarly to find the volume itself. Okay, so now if we know for the new prism, the volume, let it be V, is unknown, divided by the volume of the prism that we already know, 4250. Where did I get this from? It's from this value here. So V over 4250, is it 30 over 25 or 25 over 30? In this case, we have to use the corresponding length. It's 30 over 25. Okay, do ask yourself, since it's V, is volume over volume, so here is L1 over L2. Should it be square or should it be cube? In this case, it should be cube, since we are comparing the ratios of volumes. Hence, if we were to find the volume of this new prism, it is 30 over 25 cube multiplied by 4250. So the volume in this case is 7344 cm cube. Okay, we look at question 7 now. Question 7, the diagram shows two similar solids made of the same material. The base areas, alright, in this case, we know that the base areas are 25 to 49, and the base area of the larger solid is 140 cm square. Find the base area of the smaller one. In this case, right, since we already have the base areas of the ratios of the base areas of the two solids, so we can just simply equate. So let the unknown base area be A. So we have A over 147 is equals to, now you should take some time to think, is it 25 over 49 or is it going to be 49 over 25? In this case, it will be 25 is to 49. There is, if you're wondering why did I not square or cube this side, there's no need to. This 25 over 49 is already the ratio of base areas, and this one is also the ratio of the base areas itself. So in this case, there is no need to square or cube this right hand side. So now if we were to find A is 25 over 49 multiplied by 147. We find that the area of the base area of the smaller solid will be 75 cm square. Now in part B, since we already know that 25 over 49 is actually equals, okay, we actually know that 25 over 49 actually gives me the ratio of the areas, and we know that the ratio of the areas can also be expressed as L1 over L2 square. So in this case, what I'll go and do here is this: L1 over L2 square is equals to 25 over 49. Similar to the question that we've done before, how to remove the square here? We will square root both sides of the equation. So what I'm going to get here is L1 is to L2 is equal to the square root of 25 over 49. So what I'll get is 5 is to 7. So do answer the question. Okay, they did not they wanted is a ratio, so the ratio is 5 is to 7. Okay, for part C, if you recall, in the earlier lesson, I've said that the mass of solids, alright, is actually proportional. So the mass of solids is actually proportional to the volume, the ratio of the volume of the solids. So what we can do here is this: I'm going to let the mass of the larger solid be M. So what I'll do here is M over 8.25 is equals to 7 over 5. Alright, now take a moment, think about it. 7 over 5 actually gives me the ratio of the lengths. But in this case, what I want is the ratio of mass, and the ratio of mass is proportional to the ratio of volumes. So V1 over V2 is equals to L1 over L2 to the power of 3. Okay, so if the mass is proportional to the volume and is proportional to the cube of the length, so in this case what I'll need to do here is that I will have to cube this 7 over 5. So in the end, my mass is 7 over 5 cube multiplied by 8.25. I find that the required mass is 22.638 kilograms. The last question that we're going to cover for today is Triad 19. And Triad 19 can be found on page 74 of your Discovering Mathematics textbook. Okay, the very first part that we need to find is the length of MN. In order to find the length of MN, what we are going to consider here is to find two similar triangles. So if you notice, angle NVD and angle MVB are a common angle. Then angle VND is 90 degrees. Angle VMB is also 90 degrees. Hence, because three pairs of corresponding angles are equal, I can hereby conclude that triangle VND is similar to triangle VMB. Okay, we can use the property of similar triangles, alright, to find the length of VM. Okay, so now first and foremost, I will say this. If you remember, we go by the order of vertices 1, 2, 3. 1, 2, 3. So if I'm using Vn, alright, it will be 1, 2 over Vm is equals to Nd, which is 2 and 3, over Mb, which is 2 and 3. The working can be found over here. If I fill in the values itself, I say that Vn over 8, alright, is equals to 3 over 6. Now, if I multiply by 8 on both sides of the equation, I find that my value of Vn is equals to 4. But take note, the question actually is asking for the length of Mn and not for length of Vn. So in order to find the length of Mn, what I need to do is to take Vm minus Vn, okay, and I get the length of Mn to be equals to 4 cm. Now we move on to part B. Part B asks for the ratio of the area of the upper base to that of the lower base. So the upper base is actually in the shape of a circle over here. So this is the upper base. And we have the lower base over here. All circles are similar. So in this case, what I can do is this. I will say that they are both, the circles are similar. Hence, if you remember, for shapes, okay, that are similar, the areas are related by L1 over L2 square. Hence, since this is 3 cm, the radius of this circle is 3 cm, and the radius of this circle is 6 cm. Hence, the ratio is simply 3 is to 6 square. So we get 9 is to 36. Do not forget, right, to simplify it to 1 is to 4, which gives me the ratio of the areas. Now, for part C. Okay, part C, what we are looking for is the volume of the Fulcrum. So if you can just imagine this, how is a Fulcrum actually created? So a Fulcrum is actually created by cutting off a part of a larger cone. So if you notice, the original cone itself was V, D, and then this is how the original cone looks like. So they will cut off this portion here, V, C, and D. Eventually, what you're left with, right, is just the Fulcrum over here. So in short, what we're actually comparing is this. We're actually comparing two solids that are similar. So where are the two solids? Just imagine the part that is cut off is a solid that looks like this, and the original itself is a cone that looks like this. All right. So, and I also know that over here for the original cone, okay, these two cones are similar, and the original cone, the radius is 6 cm, and for this the part that is cut off, this is 3 cm. So therefore I can conclude from this portion here that for the two of them, all right, the ratio of lengths is 3:6 or 6:3, depending on what I actually require. So what they should give me here is that the volume of the frustum, if the volume of the cone VCD is 12 pi. So VCD, what is VCD? Is VCD the volume of the original cone, or is VCD actually the part that is cut off? Take a moment to think about it. VCD is actually the part that was cut off. So from the diagram that I drew over here, okay, VCD is actually this portion here. Okay, the part that was cut off. So they cut it off, then you'll be left with the fulcrum that looks like this. Okay, so now if we know with that knowledge, okay, let me shrink the screen a bit so I have more space to write over here. So now first and foremost, so for part C, I will say that the volume of the large cone, so I'll say volume, okay, of VAB, which is the entire cone, over volume of VCD. Okay, do I take 6/3 or 3/6? So in this case, since VAB is the larger solid, it should be 6/3. Don't forget, if I'm trying to relate the length to the volume for similar solids, what I must remember to do is to cube the ratio of length. If I fill in the values now, I will say I'll let the volume of VAB be V over 12 pi. Where did 12 pi come from? 12 pi is actually given a question. They say that the volume of VCD, or the part that was cut off, is actually 12 pi. I will find that the volume, in this case, of VAB is equals to 8 times 12 pi. How did I get 8 over here? 6 divided by 3 is equals to 2. Don't forget cube. 2 cube actually gives me 8. Hence, 8 times 12 pi will give me a value of 96 pi. So be careful here. 96 pi is not my final answer yet, because 96 pi is simply the volume of the larger cone without the smaller cone VCD cut off to form the fulcrum. Hence, okay, we must cut off the volume of the smaller part. Hence, the volume of the frustum, or the frustum rather, is equals to 96 pi, the whole large cone, minus away 12 pi, which is the volume of the small cone that was cut off. It will give you 84 pi cm cube. And that is my answer for the volume of fulcrum. Alright, thank you for watching today's video, and you can proceed to the next segment to try out the questions for your homework in ClassKick. Thank you.